Hi, how is it going? Welcome to Code with Z. In today's video, we gotta generate permutations because that's what LeetCode 47 Permutations 2 is asking us to do. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given a collection of numbers called nums, and they might contain some duplicates. And we simply have to return all of the possible unique permutations. Now, this is gonna make more sense when we check this example and we have it in the slides, so let's check it out. So we're given this array called nums and we have 1, 1, and 2 inside of it. And we gotta go from this to this. And if we check this, this is actually the permutations that we can have. We can have 1, 1, 2, which is basically the very first case that we have. And we can say, all right, we can have 1, 2, and 1, and that's gonna give us this one. And we can also say, well, we can also start with 2. We can say 2, 1, 1, and that's gonna give us this permutation. And this is all of the permutations that we can have. But let's see how we can actually go from this to this. You see, usually when we talk about finding all of the possible answers or all of the possible correct answers and stuff, we usually have to deal with backtracking. But the problem with backtracking is that it's not very easy to visualize the process. That's why I'll visualize all of it in this video, literally from the beginning to the end. But for solving this problem, we have to agree on two things before we actually start our algorithm. And when we start the algorithm, you're gonna see with your own eyes how it works. And you're gonna get it more intuitively. The first thing that we need to agree on is that we're gonna check if the current number is the same as the one before it. And if this was true, we're gonna check the second line. We literally have two lines. That's it, that's gonna be our algorithm. But if this was not true, we're gonna ignore the second line. So if in our case, the current number was actually the same as the previous one, meaning we had a duplicate, for example, these two ones that we have here, we're gonna check the second thing, and that's gonna be, if the previous number hasn't been used yet, skip the current number to avoid repeating the same pattern. This is literally everything we need. I'll put these here, and then you're gonna see how this is gonna work. So in the beginning, we're gonna start from an empty array. This empty array is gonna be our path because we're gonna be basically having a tree here and we're gonna look for the answers. And the path we take is gonna be added to this empty array. But because it's in the beginning, we obviously don't have a path, so we're gonna start with an empty array. When we start from this empty array, we're gonna be like, all right, what are our options like? What can we start with? Well, these are our numbers and we gotta use these to find the correct permutations, right? So we can be like, all right, let's see what will happen if we start with 1. We're gonna be like, let's add this 1 to our path. As you can see, we started with an empty array and then we added 1 to it. And we're gonna be like, all right, let's see what will happen if we start with 1. And then we're gonna be like, you know what? We're gonna check this possibility. We're gonna see what will happen if we start with 1, but I do also wanna check what will happen if we start with the other ones. For example, what will happen if we start with this one, or what will happen if we start with this two, right? So we wanna check all of the possibilities. When we wanna check this one, we're gonna be like, let's see what will happen if we start with this one, but we gotta check our conditions here. We're gonna ask ourselves if the current number is the same as the one before it. Well, yeah, this number that we wanna add to check what will happen if we start with it is equal to the previous number. 1 is equal to 1, right? So yeah, this one is true. And then we're gonna check if the previous number has not been used yet. If it has not been used, we're gonna skip the current number. Well, the current number is 1 and we wanna check the possibility of what will happen if we start with this one, right? So that means we only have one number. Like if we add this 1 to here, we're gonna have a duplicate of this literally here. And in that case, we've only used one of these 1 numbers that we have here. So the previous number has not been used. And here we say if the previous number has not been used, we gotta skip the current number. So we're not gonna consider this one to start with. And if we just follow these two rules, we're gonna avoid any duplicates. And if something is foggy, don't worry because I'll repeat it 100 times so I'll make sure you fully get it. Then we're gonna be like, all right, we can't use this 1 here. What about 2? Well, let's check. Is the current number, which is 2, equal to the previous one? Well, 2 is not equal to the previous number, which is 1, so we can actually have 2 here. In this scenario, we're gonna be like, all right, let's see what will happen if we start with 1, and let's see what will happen if we start with 2, like so. And you might ask, why didn't we check these two rules for this one here? Well, if we check, here it says that we gotta see if the current number is the same as the one before it. And because this one here was the first number inside of our array, no number before it existed, so we didn't need to check it. Now we're gonna be like, all right, we're gonna explore the possibility of starting with 1 and starting with 2, right? So let's explore this option here. We're gonna be like, all right, we've already used this 1 that we have here, and we wanna add this one because we want to explore our options, right? So we're going to ask ourselves, is the current number the same as the one before it? Well, yeah, 1 is equal to 1, right? Because this is true, we're going to check the second part and we're going to say, if the previous number has not been used, skip the current number. Well, the previous number is 1 and it has already been used, so we're not going to skip. We're going to only skip if the previous number has not been used. So we're going to have 2 ones. And then we're going to be like, all right, we've explored the possibility of adding 1 to this 1 that we have here. What about 2? What will happen if we instead add 2 to our 1? Well, we're gonna check if the current number, which is 2, is the same as the one before it. Well, the one before it is 1 and 2 is not equal to 1, so we don't need to check this one here, and we're just gonna add it to this one, like so. And let's expand this one as well. We're gonna say, we've already used 2. Let's see what will happen if we combine 2 with 1, right? We're gonna say, check if the current number is the same as the one before it. Well, this is the first number and there's nothing before it, so we're gonna be like, we don't care, let's add 1 here. And then we wanna add the next one. We're gonna say, check if the current number is the same as the one before it. Well, yeah, 1 is equal to 1. And then we're gonna check if the previous number, which is 1 here, has not been used. Well, yeah, we wanna explore what will happen if we combine 2 with something, right? So the previous one has not been used yet. Because this is the case, we're gonna skip the current number and that's gonna be this one here. What you gotta be careful about when we try to find these answers, we're checking these 2 conditions for this one here. And if you check, we don't have any 1s inside of this one. We only have a 2. So when we ask if the previous one has been used, well, we don't see any number 1s inside of this array, right? So it hasn't been used. And because these 2 conditions are true, we're gonna skip the current number. Meaning we're gonna skip this number that we have here. Then we're gonna explore these options. We're gonna be like, all right, let's keep on exploring further and see what will happen. We've already added 1 and 1. Let's see what will happen if we add 2 to it. Can we add 2? Well, yeah, the current number is not the same as the one before it, so we can easily add 2, like so. And then we're gonna check if we can use any other numbers, but because we've already used all of the 3 numbers, we can't check any other possibility. We could only check adding 2 to these 2 numbers that we have here, and that gave us 1, 1, 2. Now we're gonna be like, all right, we've explored all of the possibilities for this one. Let's check this one. We've already used one of the 1s and 1, 2. Let's see what other options we have here. We're gonna try to add this number 1 to our array because we've already used the first one that we have in our array. We're gonna try to add this one to our array. So we're gonna check if the current number is the same as the one before it. Well, yeah, 1 is equal to 1. Then we're gonna check if the previous number, which is this one here, has been used yet. Well, yeah, it has been used. We can see it here. So because it has been used, we're not gonna skip and we're just gonna add the next one to here, like so. Because again, we're gonna only skip if the previous number has not been used. And because it has been used, we can see it here. We can just add our 1 here. And then we're gonna expand this one. We're gonna be like, all right, we've used 2 and 1. So we wanna add another 1 to this. And we're gonna ask ourselves if the current number is the same as the one before it. Well, yeah, 1 is equal to 1. And then we're gonna check if the previous number has been used or not. Well, it has been used. So we're gonna add this one that we have here to our answer, like so. In this stage, we wanna explore further, but we've already used all of the numbers that we have and we've reached the end. How do we know we have an answer or not? Well, the length of the paths that we found are literally equal to the length of our nums array. As you can see, the length of this one is 3 and the length of these are 3. So when the length of the permutation is equal to the original array that was given to us, that means we've actually found a correct path, and we're gonna add these paths that we found to our result array at the end, and we're gonna return them. And this is everything we need. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we're gonna need is gonna be a result variable, and this is gonna be equal to an empty array. Why an empty array? Well, if we check our examples here, as you can see, this is our nums array, and when we return our paths that we found, these are our paths. These permutations should look familiar because we just saw them in the slides. As you can see, these paths that we found are all arrays and they are inside of a bigger array. So we basically have an array of arrays. And this array that we defined here that we named result is basically representing this array that we have here. So that's why we define result as an array. And then below this, we're gonna have our backtracking function and we're gonna call it backtrack. And this is gonna take a path. Now this path is basically the empty array that we saw in the slides that we started with. If you remember, we started with an empty array and then we explored what will happen if we add 1 to it, and then we explored what will happen if we add 2 to it, and then we explored those options further, right? So that path is going to be basically what we start with, and then we slowly add stuff to it. And these arrays that we have here, each one of these is going to be one of our paths that we're going to find along the way. Here, we're going to be like, if path.length is equal to nums.length, that means we have an answer, because we said when the length of the permutation that we found is equal to the original array's length that was given to us, that means we have an answer. So we're going to say result.push of path. This is basically the path we found. We're going to push that into result and we're going to return it, because that means we're done. And then below this, we got to call our function a bunch of times to explore what will happen if we start with 1, or what will happen if we start with this 2, and all of the other possibilities, right? So we got to call our functions a bunch of times. So I think having a loop is a good idea. So we say for let I being equal to 0, we want to keep on looping as long as I is smaller than nums.length, and we want to increment I on each round. Here we're going to be like, we want to see what will happen if we start with 1, right? So we're going to be like, let's explore what will happen if we add 1 to our path. Because remember, our path in the beginning is basically an empty array. So we got to add numbers to it and explore those possibilities. So we're going to say path.push of nums of I. And this basically adds all of the numbers that we have in our numbers array to our path. When we add that, we're going to be like, all right, let's call our backtracking function and give it the new path so we can actually explore that possibility. So this is going to basically take its own road and it's going to basically explore all of the possibilities that are out there with the new path. But when this round of the loop ends, we got to worry about the next round, because we're going to be like, all right, I do want to know what will happen if we start with 1, but I also want to know what will happen if I start with 2, right? If I want to see what will happen if we start with 2, the path array has to be empty for the next round, right? Because I got to explore what will happen if I start with 2. So the path basically has to be empty. For doing this, we're going to be like, all right, we've added 1 to our path. This function is going to explore that possibility. But when we come to the end of this round of the loop and we're getting to the next round and we're going to explore what will happen if we start with 2, we want our path to be empty. So we're going to say path.pop. And this is going to basically empty the path for the next possibility so we can explore that as well. And this is going to be our backtracking function. Now we need to call it for the first time. So we're going to say backtrack of empty array. Because if you remember in the slides, we started with an empty array, and this is going to be basically representing our path array in the beginning. And when this function is done, it's going to fill result with answers, and we're going to return result at the end. But if you remember in the slides, when we used a number, we didn't use that number again. Like we didn't use this one that we have here 3 times. We only used it once, right? So we got to keep track of that. We got to keep track of all of the numbers that we use. So we can have something like this. We can have an array, for example, called, I don't know, used, and this being equal to, for example, to an array that has false, false, false inside of it. And this basically tells us if a number is basically used or not. So if a number is used, this is going to be true. And if it has not been used, this is going to be false. So we got to basically here say, when we try to explore the possibility of adding 1 to our path array, as you can see here, we can say, well, because we're going to use this number, we're going to say use of I should be equal to true. This basically says, hey, we're using this number. We just want you to know that we're using it. And then we're going to pass that to our backtracking function. And when we pop it and we want to explore other possibilities, we got to assign this back to false, right? Because we want to start fresh for the next round when we want to check what will happen if we start with 2. When we start with 2, we've only used 2, and we don't want the previous numbers, for example, this one here, to be equal to true because we've not used it when we start with 2, right? We're literally starting with 2. That means none of these numbers here have been used. So now we know which one of these numbers we've already used. So let's take advantage of that information that we have. We're going to say if used of I is equal to true, meaning if that number has already been used, continue, because we've already used it and we don't want to check what will happen if we use it again. So we're going to say continue, and this is basically like saying skip this round of the loop and move to the next round of the loop. And this is going to basically prevent our code from using this number 1 that we have here 20 times. We can only use it once. Now that we have this code here, we got to make sure that we actually code out our 2 rules that we had. If you remember, we were always checking two rules. We said if the current number is equal to the previous number, check the second rule, and the second rule said if the previous number has not been used, skip the current number. Well, let's code this out. We're gonna say if nums of I, meaning if the current number is equal to nums of I minus 1 is equal to the previous number, and so this is our first rule, and this is gonna be our second rule. So if this is true, check this rule that we're gonna have here. Here we're gonna say, if the previous number, meaning used of I minus 1, has not been used, basically like so, we want you to skip. This is basically our rule that we have. We're saying if the current number is equal to the previous number, and if the previous number has not been used, we want you to skip. Now, if you remember, we always ignore this for the first number inside of our array because when we have the first number inside of our array, I minus 1 does not exist. The first number inside of our array doesn't have a previous number. So we're gonna say only check this if I is greater than 0, like so. And this is gonna make sure we don't check this rule for the first number inside of our array. Now, this code works for this example that we have here, but we don't know if the length of our array is gonna be 3, because here our used array is basically hard-coded with a length of 3, but we might have a longer or even shorter array, right? So we gotta account for that. We need an array that's equal to the length of our nums that's given to us, and we wanna fill it with false statements in the beginning, right? And we're gonna call it used. So we can basically say used should be equal to array with a length of nums.length, basically the array that was given to us. So we're going to have an array with the length of the array that was given to us, and we're going to fill it with false statements. And that's going to take care of that problem. And one more thing that we got to do is that when we push our path into our result, we can't just push this directly. We got to make a copy of it and then push that copy inside of our result. So we're going to get a copy of this, and we can basically do this by spreading that path array and then putting it inside of another array. And this is basically just how we usually copy arrays in JavaScript. Just know that we're copying this path array and we're pushing it inside of our result. Now there's only one tiny simple thing to do, and if we do that, our code is gonna work flawlessly. If we check our examples here, this array here is sorted. And when an array is sorted, the duplicate numbers actually sit next to each other. And when we have this scenario, we can easily say, for example, if the current number is equal to the previous number, that means we have a duplicate, right? But if our array is not sorted, we might have 1, 2, 1, and in that case, we're not going to be able to check for duplicates so easily. So to solve this problem, in the beginning, we're going to sort our array. We're going to say nums is equal to nums.sort of A and B, and this is basically how we sort arrays in JavaScript, like so. And this is going to basically sort our nums array that was given to us, and that's basically going to make all of the numbers that are equal to each other to sit next to each other, so you can check if the current number is equal to the previous number or not. Now, this is all of our code. Let's run it and see if we're going to get accepted or not. Moment of truth. And yep, as you can see, both of the cases are passed. Now, let's submit it and see if we're gonna get accepted or not. And yep, and we're beating 82% of all of the other submissions, even though this number is just kind of random, but that's awesome. Thanks for watching. Don't forget to like and subscribe, and keep on coding.